All right, so we're starting today by making this graph of absolute value as practice and review from previous work. And so when we go to make this graph, we look at it and we say, okay, first, what does the minus 6 do? Remember, the minus 6 that's inside with x, that moves it in the x direction. And then in this case, minus moves it specifically to the right, so we're going to go right 6. Then the minus 8, that's hanging on the end, so that's moving it in the y direction, up and down. While the x one kind of goes backwards from the way you would think, minus goes right. When we go up and down, it happens the way that you think it should. So minus 8 actually goes down 8. So our first point goes right 6, down 8. And then what is the shape of this graph? It's a V shape. And so this is then what you should end up with. Our vertex is over here at 6, negative 8. And then it is opening upward. And so we go over 1, up 1, over 1, up 1 on both sides to plot each of those points and draw in our graph. All right, and so seeing this graph and remembering what the graph looks like, now we got to go back and remember what's the range of that graph. So what is the range of this particular graph? Well, first of all, which one is range? Is that the x's or the y's? Yep, that's the y's. So we're looking at our y values here. Is this one all real numbers? No. Because notice we have y values above the vertex, but no y values below the vertex. And so then, yes, our range is going to be y is greater than or equal to negative 8. Because our y values start at negative 8, and they go up from there. Remember, range is basically a description of what's happening in this graph. It's saying this graph is going to include all y values that are at negative 8 and above. Now, I'm not going to be asking a lot about domain. That's because domain ends up being the same for all of these absolute value graphs and the ones we're looking at today. What is the domain of this graph? All real numbers, yeah. Because it goes forever left and forever right. And because it's all real numbers every single time, we aren't going to necessarily talk about it explicitly, but I just want you remembering that that's why we're not, is because they're all going to be all real numbers. All right, what we are going to be introducing today is y equals x squared. We're going to be graphing quadratics. And for some of you, this is a little bit of review. For some of you, it's new. Either way, it's good to go through and start going ahead and making this graph. And so in order to do it, since I'm treating it as new, we're going to start by making a table of values. And we're just going to grab some points and plug those in to see what those give us. All right, so first of all, if x is 0, what's y? 0, because 0 squared is 0. Okay, great. So that gives me the point 0, 0. Okay. Next up, what if x is 1? 1. Yeah, because 1 squared is 1. Okay, so that gives me the point 1, 1. I can go ahead and plot that. Next up, what if x is 2? It is 4, yeah, because 2 squared is 4, so that means over 2 and up 4. If x is 3, y is 9, yep, because 3 squared is 9. If x is 4, y is 16, which is off my graphing grid, so I'm not going to worry about grabbing any other points. Of course, we could keep going by the same pattern, like 5 to 25 and 6 to 36 and so on. Okay, so if that gets to the edge of the graphing grid going that way, then let's go ahead and see what happens as we go to the left. What if x is negative 1? What would y be? And this is one of those critical things. It is 1, a positive 1. Because negative 1 squared means negative 1 times negative 1. And a negative times a negative is a positive. That's why anytime you square a negative number, you get a positive out. And so that gives me the point negative 1, 1. From there, let's go ahead and grab the others. If x is negative 2, y is 4. Yep, because negative 2 squared is 4. If x is negative 3, y is 9. Yep, so I got negative 3, 9. And if x is negative 4, I'd get 16 as well. You plot each of those points, and then go ahead and draw the curve that goes in through those points, and you have your graph of y equals x squared, make sure you also have that equation written above the graphing grid where you plot those points. All right, and now for that graph, the y equals x squared, what is the range of this graph? Yeah. Exactly, yep, it's y is greater than or equal to 0, because you notice our y values start at 0, and then they increase from there. Now, a few other little detaily things to talk about here. This graph, y equals x squared, it is the most basic quadratic equation we can have. Therefore, we call this the parent function. We'll work a lot with parent functions this year as we go forward. Just remember that vocabulary. I just want to bring it back to you. And again, bringing back that idea about what is the domain. The domain here would be all real numbers. And that's just because this goes forever to the left and forever to the right. So now, having seen the y equals x squared graph, you now should be able to graph this equation. So write this equation above your next graphing grid, and then make the graph. So let's walk through how we are going ahead and making this graph then. That way, if you already got it, well, you got it, and you can check it. And if you're feeling stuck, how do I even approach it? Well, then we can see how. So the first thing I ask myself is, what does the minus 6 do? Notice the minus 6 is in with x. And so it moves it to the right. And the minus 8, it's hanging on the end. If I subtract 8, hanging on the end like that, it moves it which way? Up, down, left, or right? Down. Notice, take a look back at the first graph we made, the equation that we wrote for it. Notice it's the same equation as this one with the minus 6 and the minus 8 in there. The only difference is that this one is squared, not absolute value. Notice that the 6 and the 8 are still moving it right and down. And so we put our first point down here, right 6, down 8, and then from that point, remember I go 1, 1, so that means over 1 and up 1 from that first point. Remember that 2 squared was 4, so that means from my vertex I go over 2, up 4. Remember 3 squared. What was 3 squared? 9. And so I start at my vertex and count over 3, I have to count up 9. And then if I go over 4, 4 squared was 16, so I count over 4 and up 16. Notice whenever I talk about counting over and up, I'm starting at my vertex. And so notice then that those numbers, the 6 and the 8, they're telling me where to put that first point. But once I put that first point in there, it's the exact same values as we wrote in our table, just starting at this new vertex. So it's 1, 1, 2, 4, 3, 9, 4, 16, and we're just doing that along both sides. And now taking a look at those two graphs that we made, I just put them both overlapping each other here. We got our absolute value when we have our x squared graph, our quadratic graph. What's the same? Notice that one of the things that's the same is what the 6 and the 8 do. That is probably the most important thing to recognize is the same. So that means that the vertex, because both of these have a vertex, the vertex is the same for both of these graphs. It's going to be at 6, negative 8. What's different? Well, there's really only one thing different about the graphs, and that's the shape. Whenever you see absolute value, it's the V shape. Whenever you see x squared, whenever you see that squared in there, you know it's going to be the U shape. The U-shaped graph, for some of you, you've heard this before, for some of you, you haven't. The U-shaped graph technically is called a parabola. If you were spelling it phonetically, you'd probably be saying more like parabola. It's a parabola. That's the technical name given to these quadratic graphs. So I could say U-shaped graph, quadratic graph, parabola. They're all saying the same thing. So then I'd now like you to graph these 3 quadratic graphs on your own paper. A separate graph for each one. Please remember to write the equation above each graph and grid so you know which one goes with what as you look back at it later. Yes, the transformations are all still working the same way. So like in that first one, the minus in front of x squared does the same thing a minus did when it was in front of absolute value. And same with the others as well. All right, now let's actually go and make those graphs. So for the first one, we have that negative in front of x squared. The negative is reflecting it across the x-axis. That's how we describe the transformation. In other words, it's flipping it upside down. We're going to follow the exact same pattern we followed before. Now it's not shifted, so it still will start at 0. But then instead of going over 1, up 1, we're going to go over 1, down 1. And then instead of over 2, up 4, we go over 2, down 4. And so on. Notice all of the points in this pattern that we're plotting are all following that exact same pattern we saw in that table earlier. The only difference is go down instead of up. So over 1, down 1, over 2, down 4, over 3, down 9. That's all of them that fit on this particular graphing grid. Second one. In this case, the minus 3 is inside the parentheses. That means it's in with x. Therefore, it goes over, specifically to the right. And so that's how I get to my first point here. Once I'm at that first point, then once again I follow the same pattern. Over 1, up 1, over 2, up 4, over 3, up 9 on both sides, all the way along. Then for the next one, in this case the plus 5 was hanging on the end. It was not in with x, because we ended up squaring the x before we added the 5. And so that's what tells me that it's moving it up 5, not over. And so once I plot that first point up 5, well, then it's still that same pattern again. Notice I keep coming back to that same idea. So we go from that point, we go over 1, up 1, over 2, up 4, and we can't fit over 3, up 9 on the graphing grid, so I don't plot that one. Plot the ones you can, draw the curve through it. Then we are now going to do one last problem of these. Now in this one though, I'm not only going to have you make the graph, but I'd like you to also describe the transformations. That is, write out what are the transformations being applied to this graph. So things like it's reflected, it is stretched, it is shifted, and be specific about which direction for each of those. And then make the graph. All right, time to start working through this one. And I'm going to start with the transformations because in order to actually make this graph, you have to be aware of what the transformations are anyway. So let's start with this negative that's out front. That negative flips it upside down. Technically what we say for that is we say it is reflected across the x-axis. Then the minus 3 that is on the inside, it's moving it in the x direction, specifically to the right. So I'm going to say that it is shifted right 3. And actually use the word shifted. You could also say moved, but shifted is a fancier math term, so let's be fancy. And then the plus 5 on the end, that shifts it up 5. Once we've written out our transformations here, then it's a matter of just plotting each of those points. So I start by going right 3 and up 5 to get to my first point. And then the fact that it's reflected tells me go down instead of up. And so from that first point, over 1, down 1. Then from the vertex, over 2, down 4. Then from my vertex, over 3, down 9. And so on. And then finally, what is the range for this particular problem? Y is going to be what? Is this a greater than or is this a less than?
Less than.
It's a less than, yeah, because it's going down. And it's going below that first Y value, which was 5. And so your range is Y is less than or equal to 5.